All right, we're going to talk about supplementation versus substitution in grazing systems. And this is a pretty key thing to understand about managing nutrition of grazing animals. Okay, so in grazing supplementation, there's really two key questions that you kind of ought to focus on when you're trying to evaluate what supplement you should use. One key question is, what is your objective? What are you trying to accomplish with your supplementation program? And then the second thing to key in on is, what is the effect that your supplement is going to have on forage intake? Okay. You may think that something like this is what always happens with supplementation in grazing systems. Okay, what we've got here is on the x-axis here is the amount of supplement, and then this dashed line is the amount of forage intake. And so what you think may happen always is that as you're adding supplement, you're giving these animals some supplement. They're just eating the supplement in addition to whatever amount of forage they were going to eat anyway. So essentially, the supplement is just additional nutrients on top of the grazed forage, and there's really it's just an addition to the grazed forage. That's what we tend to think as our default position, and what we kind of assume happens, but that is not always what happens in reality of grazing systems. Okay, so what we're talking about here in this presentation are called associative effects in nutrition. You can have a positive associative effect, and you can have a negative associative effect. Okay, and an associative effect is basically just one part of the diet having an effect on the other part of the diet that it's fed with. Okay, like two components of the diet interacting. That's what an associative effect is. So a positive associative effect is where the supplement that you're feeding increases the digestibility or the intake of the grazed forage. Okay, so generally we would think that positive associative effects are indeed positive for the animal, for our situation, because we're getting like synergy between the supplement and the forage, right? But there also can be negative associative effects, and that's where the supplement that you feed actually decreases the digestibility and or the intake of the forage. Okay, you might think that this is always a negative situation. Sometimes it is. Sometimes it depends on your objective. Sometimes it's actually okay, depending on your objective. Okay, so let's look at a couple of these. In this case, what we have here, this is a graph showing partial substitution, and this would sort of be like a negative associative effect almost. Okay, you could think of it that way. Basically, what's happening here, as you increase the amount of supplement that you're feeding, as you go to the right on this chart, you're increasing the amount of supplement that you feed. The amount of grazed forage that the animal's grazing is going down. Okay, they're eating the supplement, and they're reducing the amount of forage that they're consuming. So their total intake, the total amount of nutrients that they're getting, is increasing, right? But it's not increasing at as rapid a rate as you're feeding supplement. The supplement that you're feeding is being offset partly by reduced intake or digestibility of the forage. Okay, so this would be a case where there's partial substitution. Also, kind of think of this as a negative associative effect. Here is a kind of an extreme negative associative effect, and this is substitution of grain for forage, and this is basically complete substitution. So you can see here as you go across this graph, as you're adding supplement, the overall intake doesn't change, and basically every pound of supplement that you feed results in a decrease in a pound of forage. So they're basically offsetting 100% of the supplement that you feed with reduced forage intake. Okay, so this would be kind of an extreme example of negative associative effect, and this is like complete substitution. Okay, so I talked about how I think it's pretty readily apparent how positive associative effects usually are pretty good. They're efficient because in situations where we feed a supplement and we improve the utilization of the forage, that usually makes money. It's real efficient. That one's pretty obvious, right? Here's an example where achieving a negative associative effect might be something that you would plan to do. These are cattle grazing really short wheat pasture. The amount of forage in this pasture is really low, and it's limiting the intake of these and the performance of these cattle. So this might be a scenario where it would be strategic to feed a supplement that would cause some substitution, that would cause a negative associative effect in intake. If we could feed a supplement that would reduce the intake of the wheat pasture, we could potentially save the wheat pasture, reduce some of the grazing pressure on it, and maybe get out of this drought or whatever situation we're in that's causing this short pasture, and be able to get the cattle through that time period so that the wheat can grow again in the future, right? So here's an example where a negative associative effect, a substitution of supplement for forage might actually be in line with our objectives. Okay. Here's an example where, well, I may just ask you, if you see cattle in an example like this, in a pasture scenario like this, what would your supplementation thought process be? Okay, would you want to maximize forage intake in this scenario, or would you want to potentially feed some kind of supplement that would offset some of this forage? Okay, and depending on what your objectives or your familiarity with this environment or whatever, you may have a different answer. But to me, this kind of illustrates a situation here where we're short of forage. We don't have enough forage to carry these animals through. And so it might make sense in this scenario to feed some kind of a supplement where we actually substitute the supplement for the forage and save some of this forage, not try to increase the demand on the forage, but actually reduce the demand on the forage through feeding a supplement that's going to cause some substitution. Okay, here's a scenario, again, back to wheat pasture, where there's lush wheat pasture, plenty of forage available. These cattle are not hurting for forage at all. We've got a lot of forage mass there. So in this kind of a situation, I wouldn't necessarily have it in my objectives to save this forage to try to reduce the demand on the forage, right? We've got plenty, so I'm going to try to feed a supplement or approach supplementation in this scenario where I don't want any substitution. I want to maximize the utilization of the forage, right? So I don't want a substitute here. I don't want to reduce forage intake in this scenario. Another example with cows, similar kind of situation. This is low quality forage, but there's plenty of it. These are cows that are dry cows. They're going to calve in the spring. And so in this scenario, the cost-effective thing to do is to promote forage intake in these cows, right? I want them to graze the forage that's out there and make the best use of it that they can, because there's plenty of it. I don't need to save any of it. So I'm going to implement a supplementation program here that doesn't cause any substitution. I want a supplement that produces a positive associative effect that causes these animals to intake more of this forage. Okay. So the thing you could think about here is the substitution ratio, where you could have a decrease. Substitution ratio is the decrease in forage intake per unit of supplement intake that you feed. So in steers grazing wheat, what we might recognize is that in our base case, if we don't feed any supplement, these steers grazing wheat pasture, we might expect them to eat 19 pounds of forage per day that they graze in the pasture, right? If we implement a supplementation with a lot of corn in this scenario, let's say we're going to feed 3 pounds of corn to these steers per head per day, then in that scenario, we might expect forage intake to go down to 17 pounds per day. So you can see we fed 3 pounds of supplement, but they reduced their forage intake 2 pounds. So if you calculate it out, 2 pounds less forage intake divided by 3 pounds of supplement is a 67% substitution ratio, right? So in this case, this corn supplement is partially substituting for the forage intake, right? This is a scenario right here. If we achieve this, this would be where we might save the wheat pasture and be able to stretch the wheat pasture out and reduce the grazing demand on the wheat pasture. Okay. So I'm going to go back here to this scenario on wheat pasture. If we fed an energy supplement with some readily available carbohydrates, because this forage has plenty of protein in it, we're not going to usually cause a great big substitution problem here. Usually the cattle on high quality forage can handle some starch, some readily available carbohydrates in their supplement, and make efficient use of that and not decrease their forage intake tremendously. Okay. In this scenario, where we've got low quality forage and we're trying to promote intake and digestibility of the forage, we would not want to use a grain-based supplement in this case. If we just nutritionally, if we put a lot of starch, a lot of readily available carbohydrate into the rumen of these cattle, we are going to drop the pH of the rumen. We're going to try to attempt to shift the microbial population from microbes that we want to be digesting the fiber, now are trying to switch over and digest the carbohydrates that we're feeding in this supplement, and we're causing a lot of antagonistic problems here going on in this animal. And if we fed corn, a grain-based supplement, in this scenario right here, this would be setting up the classical negative associative effect of grain and starch having a negative associative effect on the low quality forage. Low quality forage and starch just nutritionally don't go together. Okay. If we fed a grain-based supplement, corn-based supplement here, we would see a dramatic reduction in the amount of forage that these cattle are consuming, as well as a reduction in the digestibility of the forage. Okay, and so you can recall from our previous discussions of supplementation, cattle in this scenario, if we look at dormant native range, remember it's got moderate to low levels of TDN, but it's got very low levels of crude protein. And this kind of forage is out of balance, and it needs additional protein to bring it back into balance. It does not need additional carbohydrates, right? So it needs additional protein. In this scenario, we'd want to provide protein and not much carbohydrate to maximize the forage intake of these cattle. And indeed, if you feed a protein source to cattle in this scenario, you will see a positive associative effect, an improvement in forage intake and an improvement in forage digestibility, pretty dramatic. So that's associative effects and substitution versus supplementation, and I hope that kind of helps give you a little bit more background of how to evaluate supplement decisions in grazing systems. Thanks.